Hello class, welcome to my presentation on basic associational designs, analysis, and interpretation. The basic associational research approach examines the relation between two continuous variables, or at least ones that have many ordered levels, leading to a correlation coefficient. The most common correlation coefficient used to describe the relationships between two continuous variables is the Pearson product moment correlation. The Pearson product moment correlation provides an index of the strength of the linear relationship between two continuous variables. The Pearson correlation is widely reported in the literature for evaluating measurement reliability when one might test the relationship between two administrations of the same instrument. Test, retest reliability. The Pearson correlation assumes that the distribution of the dependent variable is normal, with equal variance for each value of the independent variable, and assumes that the independent variable is also normally distributed. The Pearson correlation is expressed as a coefficient, R, which indicates the strength of the association or relationship between two variables. This coefficient has a range of -1 to +1. A positive relationship means that as scores on one variable increase, scores on the other variable also increase. The degrees of freedom for a Pearson correlation coefficient are the number of participants in the analysis minus 2. In statistics, the degrees of freedom refer to the number of values in the final calculation from the data collected in a study that are free to vary. When one or both variables is not normally distributed, or there are violations precluding the use of parametric statistics, the Spearman correlation or the Kendall-Tau is usually used. The Spearman correlation, the more common of the two, was named after English psychologist Charles Spearman, known for his work in statistics as a pioneer of factor analysis, and for Spearman's rank correlation coefficient. Spearman's rank coefficient is a non-parametric measure of rank correlation, which is the statistical dependence between the ranking of two variables. It refers to an increase in scores on one variable and is accompanied by an increase or decrease in scores on the other variable, but this change in scores is not necessarily linear. Both the Spearman correlation and the Kendall-Tau are performed on ranked data rather than original scores. When the sample is relatively small, and some of the rankings are the same for different participants, ties, the Kendall-Tau is the appropriate non-parametric choice. It is not uncommon to make incorrect inferences from the correlation coefficients. We can only make inferences about causes if the design is a well-constructed, randomized experiment. To summarize, we talked about the three basic associational designs: the Pearson product moment correlation, the Spearman correlations, and the Kendall-Tau. We concluded that correlation coefficients are most common in associational, non-causal research approaches. Hence, one should not infer causation from correlation. However, the correlation, even in the absence of causation, might be strong, moderate, or weak. That concludes my presentation. Thank you for listening.